Good morning, everyone. We are Team 4, and this is our final presentation on ALACen automatic language level adjustment for video censorship. We are going to revisit the overall idea and objective of ALACen, followed by experiment, results, limitation, future work, and conclusion. Since we work on censoring video, it's to be noted that this presentation may contain video, speech, text that are offensive in nature. Let's review the overall idea of our project. Traditional way of film censorship is often manual and repetitive. It took a long time and cost a lot. In addition, it is hard for the audience to fully enjoy censored film. Thus, our group wants to automate the adjustment of language level for censorship by starting from a short monologue videos with violent speech as a prototype for this research field. We aim to paraphrase the violent speech in the videos and synchronize the content back via lip sync and voice style transfer to finally achieve the videos with adjusted language level and lip synchronization. In conclusion, our project aims to develop a novel method for performing video censorship that is automatic and does not disrupt the enjoyment of the audience. ALACen contains 4 main components, namely speech recognition, paraphrase generation, text-to-speech synthesis, and lip synchronization. Each component we use the following model. First, our speech recognition model is Whisper, which is very robust to accents and background noise. Second, our paraphrase generation is a fine-tuned Pegasus. It is originally a text summarizing model. However, its fine-tuned version is one of the best paraphrasing language models as of now. Third, our text-to-speech is voice trap, which is able to perform zero shot and text-to-speech using just 3 seconds of an unseen audio sample. And lastly, we use lip-to-lip for lip synchronization. The model has greater performance than its peer because it can use audio as a context. Next, we will be experiment we perform on our project. Let's start with our dataset. Firstly, we want to create our own violent speech dataset that contains sentences with offensive language and its label that are non-offensive but have the same meaning. As there is no language model that can perform the task of censorship, this violent speech dataset will be used to fine-tune the language model for paraphrasing violent to non-violent speeches. The diagram on the slide shows our dataset construction by line, which can be divided roughly into 3 steps. The first step for creating the violent speech dataset is pre-processing. We first acquire the movie script dataset, which is freely available on GitHub. The dataset contains the script of 2,660 movies downloaded from the script on the screen website. Then the scripts were passed into sectors, and the parts that correspond to characters, utterances, or dialogues were extracted. As a result, we obtained over 2 million utterances from the movie script dataset. Some utterances may contain multiple sentences, while some contain only a single word. After obtaining the collection of utterances, the next step is violent speech extraction. In this step, we will extract the utterances that contain violent speeches. To this end, we use a BERT-based LM trained on Twitter comments and fine-tuned on a movie subtitles dataset to detect violent speeches. Out of over 2 million utterances, we extract and collect only those that the LM identifies as offensive or hate speech. As a result, we have a collection of almost 90,000 violent utterances. Then the next and most crucial step is reference paraphrase generation. In this step, we use an LLM to paraphrase violent speeches into non-violent speech to be used as a ground truth in the LLM fine-tuning. To do this, we use zero-shot prompting on Google Gemini's 1.5 Flash and 1.0 Pro API by giving them an explicit instruction to paraphrase the given sentences. From around 87,000 violent speech, we then randomly sample paraphrase pairs and get 19,000 sentences to feed it to Gemini to get the non-violent sentences. However, the violent speech dataset contains a lot of data with undesired characteristics. For example, sometimes LLM might refuse to generate label due to its output violating its own ethic code. The output sentences will be in a similar wording as above, like "I can fulfill your request" or "I can paraphrase the sentence due to something something." Some may contain Unicode character in this form of string. Some may have an excessive amount of space, and some may contain unrelated words. Therefore, there is a need for further filtering so that the fine-tuning process will proceed smoothly. These are some examples of characteristics that we filter out. Other than the example I mentioned earlier, there are also a redundant use of parentheses. A sentences that enclose in backspace have a space between words or the input that are not a dialogue, but rather a narrative or a setting. We manually validate the data if it contains this characteristic and get our final set of violent speeches. To summarize, we obtained 2 million utterances from the movie script dataset, extract only 87,000 that are violent, and generate ground truth using Gemini from the randomly sampled paraphrase pairs with the amount of 19,000. After that, we filter out some dataset that contains words, various undesired characteristics, and finally, we are left with 14,000 labeled datasets on violent speeches and its non-violent paraphrase form. Here are some examples of violent speeches and their paraphrase counterparts in the dataset. We can observe that the paraphrasing process is a complex task, but the ALACen was able to handle it well. This highlights its ability in paraphrase generation. The next dataset is the violent video dataset that will be used for evaluation. Our dataset includes 20 short video clips, each lasting between 4 to 7 seconds, featuring monologues with violent speech from movies and TV shows. We start by looking at lists of movies and TV shows known for their violent language. Then we search for specific scenes on YouTube that match our need. Once we found the right clips, we extract the short scene we needed. If a scene had more than one character, we crop it to focus on the person speaking. So for clarity, we will have a total of 2 datasets, violent speech dataset that will be used for fine-tuning our language model Pegasus, and profane short video dataset that we will use to evaluate the performance of ALACen as a whole. Now that we get all the datasets, the next task is to fine-tune our paraphrase generation model Pegasus. The first experiment will be about fine-tuning Pegasus model. For the process of fine-tuning, we start by downloading the model from Hugging Face. This Pegasus is the text summarization model that was fine-tuned to do paraphrasing tasks. However, it cannot censor offensive speeches reliably. We fine-tune this model on our violent speech dataset that we created in the previous step. We split the dataset into 80% for training set and 20% for testing set, and then train for 4 epochs. After the process is complete, we get our Pegasus model that can both paraphrase sentences as well as censor offensive words in one go. Note that from the original Pegasus model that we download, they set a configuration that limits sequence token to 60 tokens. Therefore, any input that have token length longer than 60 will be truncated. Next, to evaluate the 5G model, we employ 3 different text generation metrics, include meteor, burst score, and syllable count difference. To provide a reference point, we will compare the evaluation results of our 5G model called Pegasus ALACen with the original model called Pegasus Paraphrase. Let's talk a little bit about evaluation metrics. The first metric is called Meteor, which was originally developed for machine translation tasks. It considers the similarity between the generated text and the reference text, taking into account word ordering, stemming, and synonym. We use it as it is more aligned with human judgment than the traditional blue or loose score. The second metric is burst score. It was developed for text summarization tasks, but also widely used in other text generation tasks as well. It utilized embeddings from burst models to capture the semantic similarity between sentences. It is also highly correlated with human judgment. And finally, the last metric is syllable count difference, which we newly introduced. This metric computes the difference in syllable counts between the generated and input text. And we include this metric to see how well the generated text match the input text in terms of speech duration.
Okay, so next let's move on to the next experiment. In this experiment, we are going to evaluate the full ALACen pipeline. So before talking about our procedure, let's take another look at the ALACen pipeline. As previously explained, ALACen consists of 4 main stages or components which are executed sequentially. So in this way, instead of simply passing in the input video and waiting for the final output, the user can interact with ALACen and select or modify the output of each stage. For example, a user can edit the output transcript from the speech recognition stage, select or edit the paraphrases from the paraphrase generation stage, and pick the best generated speech from the text-to-speech synthesis stage. In other words, a user can balance between the convenience from the autonomy and the quality of the censored video. So accordingly, we design ALACen to operate in two modes. First is the fully automatic mode, which we will call auto, and the second is semi-automatic mode, which we will call semi. In the auto mode, ALACen executes without any human intervention. However, instead of generating a single paraphrase or speech audio for each input, we exploit the non-determinism of the generative models and generate multiple options. In this way, ALACen must be able to automatically select the best output based on some predefined criteria. On the other hand, in the semi-mode, the user can interact with ALACen at each stage to edit the transcript, select or edit the paraphrase transcript, or select the best generated speech from the text-to-speech synthesis. So this is performed to obtain the best possible output according to the user's judgment. So in our experiment, for the auto mode, we focus on paraphrase generation and text-to-speech synthesis. For paraphrase generation, ALACen generates 5 paraphrase transcripts with a temperature of 0.5 using paraphrase ALACen. Then, as a heuristic, it selects the paraphrase transcript with the syllable count closest to the original transcript. So similarly for the text-to-speech synthesis, we generate 5 speeches from the selected paraphrase transcript and pad or truncate the generated speech to the length of the original speech. Then for the heuristic, we select the generated speech with the audio duration closest to the original speech or the input video. We use these two heuristics for the paraphrase generation and text-to-speech synthesis because in real applications, we want the censored video to be easily put back into the original full movie or video without changing its duration. Next, in the semi mode, similarly, we focus only on the paraphrase generation and text-to-speech synthesis. For paraphrase generation, ALACen generates 5 paraphrase transcripts, and the user will select the best paraphrase that best suits the context and matches the length of the original transcript. And for text-to-speech synthesis, ALACen also generates 5 speech audios, and the user will select the best generated speech based on the tone, accent, pace, and rhythm of the original speech. Lastly, the single output of the lip synchronization stage generated from the synthesized speech and the original video will be used as the final output. So after describing the two modes of operation, let's dive into the detail of this experiment. In particular, we evaluated the ALACen pipeline by conducting a user study in terms of the user's quality of experience. That is, we asked the users or participants of the study several questions to evaluate the quality of the censored videos in different aspects, using the absolute category rating scale, which is shown in the table on the left. The rating scores range from 1 to 5, such that 1 means bad and 5 means excellent. We then average the rating scores of all the participants to compute the mean opinion score, or MOS, which is our final evaluation metric for this user study. So here are the 5 questions we asked the participants. They include: how natural do the lip movements look? Does the audio match the lip movements? How easy is it to understand the content? How well does the adjusted language fit the context? And how satisfied are you overall? And note again that the users give scores of 1 to 5 for each question. Next, for the procedure of the user study, first, the participants are asked to watch an original video from our video dataset. Then they are asked to watch the video censored by ALACen's auto mode and evaluate it by comparing it with the original video. Next, they are asked to watch the video generated by ALACen's semi mode and similarly evaluate it. We repeat this process for all the remaining videos, and note that the participants did not know which videos are the result of the auto and semi modes. 15 participants were included in this study, and each participant evaluated all the 20 videos in the profane video dataset. Specifically, we conducted the user study using Google Form, and here's an example question for one video. The participants were asked to watch the videos and evaluate them in the order of the form, and each participant can fill in the form only once. And this is the end of the experiment section. Now let's move on to the results and discussion. So first is the results of fine-tuning the Pegasus model. As previously mentioned, we fine-tuned the Pegasus paraphrase model for 4 epochs on our violent speech dataset. And the two figures on the right show the training loss over the training steps and the test loss at the end of each epoch. The final evaluation results are shown in the table, and we can see that the fine-tuned Pegasus ALACen demonstrates a significant performance improvement across all the evaluation metrics. And this shows that the paraphrases generated by the Pegasus ALACen are more semantically aligned with the reference paraphrases than the ones from Pegasus paraphrase. More importantly, we can observe that a significant improvement in syllable count difference, which is our important target. The improvement stems from the fact that Pegasus paraphrase is obtained from fine-tuning Google's original Pegasus model, which is trained for text summarization. So Pegasus paraphrase also tends to generate texts that are shorter than the input text. Here are some example input texts which contain violent speeches and the content paraphrases from the two models. We can see that Pegasus ALACen can censor inappropriate words while producing the paraphrases that better suit the context than the original Pegasus paraphrase while keeping the details and preserves the input text length. So next, after looking at the paraphrase generation results, let's see what ALACen we implemented looks like. To show this, we have developed a demo application with Gradio, which is currently deployed on the EE474 G7 server. If you are interested, you can use the link here or use the QR code on the slide. And the link will be expired on June 13th at 9 p.m. as we do not have a permanent URL. So here is the appearance of our demo web app. And we provide a demo video, but it can be replaced with users' videos. And to run ALACen, you can simply click Run All at the bottom of the page after uploading the input video, and this will execute ALACen in the auto mode by running all the steps sequentially and producing the censored video in one go. And you can also run ALACen in the semi mode by running each stage manually step by step. And to show how ALACen works, I'll walk you through the app step by step. Okay, so the first stage is speech recognition. In this stage, ALACen generates a transcript of the provided input video, and you can edit the generated transcript in the text box. The next stage is paraphrase generation. After running ALACen, ALACen will generate 5 paraphrases of the original transcript. The outputs are sorted by the syllable count difference, and you can also edit the selected paraphrase in the text box at the bottom. And the next stage is text-to-speech synthesis. When running, ALACen will ALACen will take the original speech and the selected paraphrased transcript to generate a new speech that imitates the voice of the original speaker. And you can rerun this multiple times as the generated speech may not always be acceptable. The last stage is rip synchronization. After running, ALACen will produce a censored video which can be used as the final output or further adjusted for better quality.
So here is the result of user study for both fully and semi-automatic pipelines. There is 13% improvement from the fully automatic pipeline, which is 3.12 to 3.53. Next, the top 3 best and 3 worst results of each pipeline will be shown. So, next slide, please. Okay.
Your self-preservation as a matter of survival is crucial to act swiftly and decisively.
I would appreciate it if you could tell me immediately what you're planning to do to make me feel uncomfortable.
He used a lot of marijuana and had to compose a song called Hello, My Name Is...
Okay, let's continue with top 3 worst results from the fully automatic pipeline.
Look,
You want to be a role model, go out there and do things. My eyes are wide open.
Strongly in this, I do because I believe strongly in it. Off declines. We should all be prepared to share our thoughts and ideas.
Okay, so now we are going to see the top 3 base results from the semi-automatic pipeline.
He was so high on weed that he had to write a song called Hey, What's My Name?
If self-preservation is an immediate priority, it's crucial to act quickly and decisively.
I would appreciate it if you could explain what you intend to accomplish to make me feel compelled to act.
Okay, now lastly, let's look at top 3 worst results from semi-automatic pipeline.
That's your fortress of solitude. It sets you back so much that you can't believe you're even here. Livestock to clients. It's your responsibility to provide quality service.
All right, everyone, let's see what you think. And then we'll make our own decision.
Okay, so there might be some problem on the sound from my side, but I'm not sure about on the classroom side. But for TA and professor, I think that you can see from the thing that we sent to you that there is some improvement from semi-automatic pipeline, from automatic pipeline to semi-automatic pipeline. Now let's look into the interpretation of this question that we have presented before. Now we are going to use the term evaluated aspect in order to talk about our user study result. Next slide, please. So the results highlights how human intervention improves user satisfaction. In the automatic pipeline, most users rated their satisfaction as poor or fair. However, with the semi-automatic pipeline, satisfaction ratings shift notably toward fair and good, demonstrating that adding human intervention leads to a more favorable user experience. Next, please. This graph shows the delta of user study result, and it shows that the semi-automatic pipeline consistently outperforms the automatic pipeline in every area, including overall satisfaction. This indicates that adding human intervention significantly boosts performance in this aspect. Next slide, please. Next, this graph highlights the specific improvements achieved through human intervention. We see the highest gains in context fitting and content understanding, respectively. And lip synchronization and lip movement also show notable enhancements as well, thus showing the positive impact on human intervention in every evaluated aspect. The degree of improvement of context fitting is number 1, while lip movement is the least. Next slide, please. Let's dive into the discussion on the significance of each module. We notice the roles of whisper and lip-to-lip in enhancing user satisfaction. Whisper, our speech-to-text model, excel in transcription accuracy despite user-side variations, with few mistakes from limited samples. Lip-to-lip, our lip synchronization model, benefit from advancement in text-to-speech and paraphrase generation, leading to improved synchronization. These models help to address challenges in lip movement and synchronization with lesser improvements compared to other metrics. Next slide, please. Next, we focus on Pegasus and Whitecraft, our paraphrase model and our text-to-speech model. They enhance overall satisfaction and content understanding by refining language quality. This makes censor video content easier to understand. Their contributions are crucial in context fitting and ensuring effective lip synchronization by providing clearer, contextually accurate audio, thus facilitating better user experiences. Next, we are going to show how human intervention creates an impact on the paraphrase model and text-to-speech model. Next slide, please. Here is the example of impact of human intervention on paraphrase model. From the original transcript, as you can see, the purple text, tell me. It turns to something that is out of context, like tell me about yourself in the paraphrase, without human intervention. But when we use human judgment or human intervention, the paraphrasing, the context of content is more similar to the original. Now is the example of impact of human intervention on text-to-speech model. Let's start with the original speech.
You said, how do I know you said I'm funny? How the fuck am I funny? What the fuck is so funny about me? Tell me.
Okay.
I'm not
So
sure what
now,
I'm saying. You said I'm funny, so I don't want to be funny. What's so funny about me? Tell me.
nothing. Yes.
Then he said, I'm not sure I understand. You said I'm funny. How are you making fun of me? What's so funny about me? Tell me.
Okay, so as you can see, without human intervention, the speech does not sound like original at all. But with human intervention, it sounds better. Okay, let's continue with limitation and improvement. Next slide, please. So, before obtaining our results, we identified key limitations in our approach. Initially, we were limited to monologues with single scenes that make us to consider the introduction of speaker separation and automated cropping for multiple speakers as inputs. Additionally, human intervention was crucial for acceptable performance at early development stages. To address this, we plan to develop criteria that mirror human judgment more closely and train ASR transcription in conjunction with paraphrasing to enhance speech quality. Next slide, please. And then, after obtaining our results, we identify additional limitations. Background noise and music negatively impacted our text-to-speech generation, thus complicated content understanding. To address this, we plan to implement track separation techniques to separate between background noise and music with the speech, and train more robust text-to-speech models that are resilient to background noise. Another issue was abnormal pausing and pacing, where current paraphrasing and text-to-speech models fail to effectively control the audio timing. We aim to fine-tune text-to-speech model for better audio duration, matching, and enhanced paraphrasing in corporate natural concepts, improving the overall quality of video and comprehension of speech. Next slide, please. We also discovered limitations in mouth generation and lip synchronization. Traditional face recognition models that is designed for static faces is struggle with dynamic lip movements in movie scenes, leading to synchronization glitches. To address this, we propose using 3D reconstruction or face recognition model that can use moving face as an input. Additionally, the quality of paraphrasing was affected by our off-context speech generation, making accurate paraphrasing challenging. We plan to develop a more comprehensive dataset specifically for paraphrasing non-violent speech to enhance contextual accuracy. Next slide, please. Okay, next will be what long-term future plan ALACen might look like. To transition our system to real-world application, we need to address several areas. First, we need to generalize to complex scenes. We must adapt the system to handle scenes with multiple speakers and frequent cuts. Next, we are going to integrate with editing pipelines to seamlessly integrate the system with existing movie and video editing workflow. And lastly, algorithm enhancement. We are going to we need to find a more effective algorithm to automatically select suitable paraphrase content and generate speech is needed. For the conclusion, so ALACen can be the beginning of the new breakthrough of modern film censorship. From all of our pilot projects, ALACen can automatically and innovatively censor violent speech in films under certain constraints, such as single scene monologue, no background sounds, and minimal face movement. But currently, it still requires human intervention to achieve high performances. And also, it offers a potential solution for some group of audiences who possibly access improper materials. But we need further study in order to understand and to compare it with traditional methods like beeping on platforms like YouTube. So here is our references. Thank you for your attention.